Okay, so we continue once again with examples in the linear homogeneous second order ODEs. And this time we have the following example. We have y double prime minus 14y prime plus 49y equals to 0. And you can see we were given initial conditions. We have that y of 0 equals 0 and 1 prime of 0 equals 1. So if we're given initial conditions, we use them to find whatever our solution is. And you can see that for the first orders, we only get one condition, but because this is a second order, we now get two initial conditions, y of 0 and y prime of 0. So let's solve this one. So if you remember from last time, our first step when solving this will be to write our characteristic equation, because this one you can see it's also a constant coefficients example. So for this one, our characteristic equation once again will be lambda square minus 14 lambda, just lambda, right? Because that connects with the y prime, plus 49 because the y doesn't have, it's not a prime, so it would just be the 49 by itself. And this is equal to 0. So to solve this, you can use whatever method, quadratic equation. In this case, we're going to be using factoring. So you can see to factor this out, this one I know it's factorable. So we have lambda and lambda, and then we need a number that multiply gets 49 and add up gives me 14. So the only one I can think of, and since that's negative and negative, then I mean negative and positive, we need both numbers are gonna be negative. And the only one I can think of it's 7 and 7. So negative 7 times negative 7 gives me positive 49. Negative 7 plus negative 7 does give me negative 14. So you can see we're going to get here that lambda minus 7 equals to 0. Therefore, lambda is equal to 7. For this other one, we happen to get the same thing. Lambda equals to 7. So you can see, even though we can still name them lambda 1 and lambda 2, you can see that for this experiment, or this one in particular, lambda 1 is equal to lambda 2. And because both roots are the exact same sign, same number, this means that we got a case 2. And whenever we get a case 2, our solution is in the form of y equals to c1 e to the lambda x plus c2 times x e to the lambda x. So that being the case, let's apply this and we get the y of x is equals to c1 e to the 7x plus c2x e to the 7x. And this is what we will call our general solution. So general solution. But you can see that we were giving at the beginning these two initial conditions. So in order to apply them, we need to first also take the derivative of the solution so that we can use the y prime condition. So let's find that derivative. And we are going to get here, if we take the derivative of our solution, we have then the y prime of x, it's equal to, this will be 7c1 e to the 7x plus, okay, so this one, we have two functions basically, so we will need to find, to apply product rule. So let's take the derivative of the first one times the second term. So the derivative of x is just 1. So this will be c2 e to the 7x plus the derivative of the second one times the first which then will be times 7 c2 e to the 7x times x. So that is our term. You can see these two, basically they just come from finding the derivative of this one. All right, so we have our two solutions. Let's apply our initial conditions. We have that y of 0 equals 0. So let's see that. So we have here that when y of 0, when x is 0, y will be 0. So then we said this one will be 0 equals to c1 e to the 0 plus c2 times 0 e to the 0. And you can see from this one, basically we can get rid of this. This becomes a 1. And then we're left with the answer that c1 is equal to 0. So we got rid of one of our variables. All right. Now let's apply the second condition here. And this one will be y prime of 0 equals to 1. Correct? Yes. So we will have then that 1 is equals to 7 c1 e to the 0 plus c2 e to the 0 plus 7 times c2 e to the 0 times 0. Okay, so from here, we already know that c1 is 0, so we can cancel that one. All of this is multiplied times 0, so we can cancel that one. E to the 0, it's 1. And so from here, we are left with c2 being equal to 1. So we got our initial conditions, and now we can apply that, and we can find our final solution, our particular solution. And we're gonna get that y of x is equal to then just x e to the 7x, because c2 is equals to 1 and c1 is equals to 0. So this is our particular solution for this problem. As you can see, this problem is pretty straightforward. Once again, there's nothing complicated about it. You can see the steps that we took to solve it. There are not that many, and if you're giving a problem like this, it's pretty easy to check. So that's it for this problem. I'll see you in the next one.